When I was 20, I took a trip to Europe. I backpacked around for a few months, and my friend Dana at the same time traveled to Israel. Now we made this plan to meet somewhere in between, and Greece seemed like the place. We figured we'd meet on a beach in Greece. But we didn't have proper communication tools at that time, and fate had other plans for us. As I was traveling down through Italy, I realized I had gotten sick, and I decided that I had to head home. The only flight I could get was out of Paris, so I got on a train and I headed to Paris. And I figured I would call Dana in a couple days when I got back to California. Meanwhile, Dana was waiting for my call, which wasn't coming. She got an invitation from her friends to go to Paris, just for the weekend. And initially she said no, because she had to wait for my call. If I called while she was away, she would never meet me. There's no way we could get in touch. Finally, she changed her mind and decided to go to Paris with her friends. So I had about 48 hours before my flight, and I went to the Louvre Museum in Paris. Very big museum. As I'm walking through the museum in the afternoon, I'm looking for the Mona Lisa, and I turn this corner, and I just stare. I'm really confused. It's not the Mona Lisa. It's this person that looks just like Dana. And I can't figure it out, because I know that Dana's in Israel. That my mind is convinced of. But the more I look, the more this person looks like Dana. So I'm standing there staring, and her friend catches sight of it and looks at her and says, "Don't look now, but there's this really weird guy staring at you." Dana did look up, and luckily she acknowledged that she knew me. And as it turned out, we met by accident in Paris, in the Louvre Museum, when we had met to meet in Greece. This experience made it really clear to me that there's got to be a better explanation for how these events show up in our life. Not only had we been best friends for 7 years, I mean, I could have met anybody walking through somewhere in Europe. That happens. But not only had Dana been my best friend for 7 years, not only was she ultimately my soulmate, 10 years later we got married. Now we have a 10-year-old daughter. But the main point is that we were intending to meet in Greece. We made a plan to meet in Greece. And when things got derailed, life shifted around to bring us together in Paris. So how is that possible? This experience and a lot of other experiences, maybe less dramatic, got me thinking about how to explain synchronicity through a scientific model. And that's what I'm going to present to you today. It starts with the idea of a branching tree. In physics, in quantum mechanics, we describe the evolution of things like electrons or photons, which are particles of light, through the image of a branching tree. Every time one of those particles interacts with some other system in the world, it branches into different possibilities. And it's these possibilities that quantum mechanics describes. None of the actual branches of that tree are actualized until a measurement is made of the electron or the photon. Now I'm going to take a dramatic step, a controversial one, and apply this model to everyday objects, in this case to Dana in the Louvre Museum. And I'll justify that some later, and my research has been to understand why this must be the case. But for now, we're going to take this model and apply it to Dana walking through the Louvre Museum. Now, when I walk into the Louvre, I interact with a branching tree of possibilities. Her branching tree. And some of those branches involve her being in Israel, of course. I assumed that's where she was. But clearly some of them involved her being in the Louvre Museum, because that's where I am, and that's where I ultimately met her. So you can see from this, I'm the blue line, and I walk into the museum, I'm interacting with 3 different possible branches of her tree. On one of them, she walks off into a room I never go into. But in 2 of the branches, she's in a hallway that I might go down. And the key idea here is that if I take a right down the first hallway, I might run into her, because one of her branches leads there. But if I make a different choice, just because I randomly decide to do so, I can go down the long hallway and end up meeting her there. This is a case of flexible histories. If I go forward down the hall, I meet her there, and the other 2 branches disappear. But if I make a different choice, one of the other branches can become actualized. This is an example of flexible histories. From my point of view, Dana's history is flexible. It can adjust itself based on this branching tree in order to accommodate the choices that I make. Now, it's certainly true that from my point of view, this looks a certain way. And the same must be said for her. From her point of view, I would let go of everything I know about my world and I would step into her world. And then I would describe a branching tree about me making my different choices. And we'll come to that later. This model applies to each of us in our own individual worlds. So what is a synchronicity? A synchronicity is a meaningful circumstance which becomes more likely because it leads to an experience you're seeking to have. In this example, we can visualize this tree with lots of apples on it. The branches of the tree represent all the different ways that circumstances can unfold in the world. All the different hallways I could turn down, hallways she could turn down, her going to Paris or not going to Paris in the first place. The apples represent the experience I want to have. The apples represent me connecting with Dana while we're traveling in Europe. That's an experience. It's a combination of thoughts, feelings, and emotions which I have when I'm with her. And there's many branches of the tree on which I have those thoughts, feelings, and emotions. So I'm going to place apples on those branches. Now, the key idea of synchronicity here is that those apples arrange themselves in many different places on the tree, but you can see in the top left, there's a branch with a lot of apples on it. Now, that branch involves us being in Paris together. If I go to Paris and she goes to Paris, there's a lot of different ways we could meet. We could meet at the Louvre Museum, which is what we did. We could also meet at a cafe, or at the Eiffel Tower, or at a nightclub. These are all different branches of the tree, but they all satisfy the criteria of having that feeling of connection that we have when we're together. So these apples get placed on those branches, and it weighs down that whole section of the tree. The whole left branch there gets heavier from all those apples. So what does that do? It adds to the probability that that branch will actually happen. And here's the key point. In order for that branch to happen, Dana has to be invited to go to Paris. That is a coincidence. I'm going to Paris, and then she gets invited to go to Paris also, unbeknownst to me. But that coincidence is necessary in order to lead to all these apples, all these possibilities where we connect in Paris. And so it's the future apples, the experiences I want to have that weigh down that branch and make it more likely that anything that leads to that branch is going to happen. So the moral is it becomes more likely that Dana will be invited to go to Paris precisely because it leads to a lot of possibilities where she and I have the experience that we want to have. That is the proposal here. It relies on flexible histories. So let's talk about how flexible histories come about. As an example, consider light leaving the sun and traveling to Earth. As it moves through space, it takes 8 minutes to get from the sun to Earth. But it doesn't just travel in a straight line. It branches into many different possibilities. And through a process I call retroactive event determination, it's the end point that determines what path it actually took. So there's 8 minutes of time during which the light might bounce off a dust particle and go left or right, and do that again and go different directions. These are all the possible paths that the light might travel. And this is a single photon. There are trillions of photons heading to Earth at any given moment. This is just tracking a single one of them. And if you walk outside and you feel that photon on your skin, you are actually observing the light that traversed the distance from the sun to your skin on Earth. But if you observe it, it must have hit Earth. And if it must have hit Earth, it must not have gone on all these other branches. So what we see is that the end observation makes retroactively the path unfold, which led to the light traveling directly to Earth. You see, the actual path becomes determined after the fact. The fact that I feel the light on my skin on Earth means that it must have traveled along this distance, that it must have traveled along this line to get to me. Now let me ask you what would seem like a simple question. Where was the light 4 minutes ago? Well, you might say it was halfway between the sun and Earth. 4 minutes had gone by, it had traveled halfway. But you can't say that because 4 minutes ago, there was not a definite reality for the light because you had not observed it hitting Earth yet. So you don't know that it was on that path. And in fact, it can't be said that it was actually on any given path. Instead, we have to say it's in some combination of all the branches of the tree. All the possibilities existed for the light 4 minutes ago. It's somewhere in that oval. So this is retroactive event determination, where events in the world unfold based on the outcomes that make them necessary. The path of the light becomes what it was as a result of the fact that we observe it here on Earth. Can we apply this, really, to macroscopic objects? It's been well studied and established in mainstream science that we can't apply quantum mechanics to the macroscopic world. But we need to back up a little bit. The reason we've made that decision is because we don't see branching trees of possibility in the everyday world. When I go out to my car is in a different location every time. When I met Dana in the Louvre, she was in a specific location in the Louvre. I never see her in multiple places at once. But we never see electrons in multiple places at once either. Quantum mechanics is the study of what things are doing when we're not watching them. When we're not watching electrons and photons traveling through space or through an experiment, they're branching into possibilities. And when we do make an observation of them, when we do interact, we get a single outcome, just like we do in the world around us. So what would you expect to see if quantum mechanics was actually applicable to the everyday world? You would see a world just like this one. You would see everyday objects showing up in your life as if they had fixed histories to them that brought them to that point, as if the world was going on outside of your realm of observation without you. And yet, it's possible that objects are evolving in many histories until the moment you observe them. And what's required is what we call relationality. One of the main theories that explains why we supposedly don't experience quantum mechanics at the macroscopic level is called decoherence theory. And what it says is, we know that when you observe something, it collapses into a definite state, a single reality. But big objects like you and I are being observed all the time by air molecules bouncing off our skin, by photons hitting us from the light and from the sun. We're being observed by each other, by the chair we're sitting on. And all of these things supposedly collapse us into a specific state. All of these things make macroscopic objects take a definite reality. We are essentially being observed by our environment all the time. But in the relational model of quantum mechanics, the idea is that these interactions we have with the world are relative to each other. When I interact with Dana, I am observing her and she is observing me. But we are not observing the whole world. One of the original papers supporting decoherence theory says the following: there is simply no need for collapse in a universe with no systems. So we shall feel free to assume that an environment exists. If we assume that an objective and definite environment exists out there, a real world that we're interacting with, then yes, everything collapses, everything takes a definite form relative to that environment. But the math of quantum mechanics really says that everything is just taking correlated states relative to each other. Physics is about interactions. When I interact with Dana, we correlate our worlds together. We would now agree on what we observe together, but that doesn't mean that the whole world is objective. That doesn't mean the whole world is no longer a tree of possibilities. And this is what allows the flexibility of histories of even macroscopic objects, I suspect, to unfold in ways that may be even beneficial to us. If you start with the assumption that the tree of possibilities don't apply to macroscopic objects, then that's what you get. And that, I suspect, is how we've gotten to the conclusions we've drawn about macroscopic quantum mechanics. or quantum mechanics in the everyday world. So let me ask you a question. What's happening next door right now? You don't know. You're not observing it, so you don't know. But you would assume that surely something definite is happening. Something is happening, you just don't know what it is. What quantum mechanics would imply, if it applies to macroscopic objects, is that not only do you not know what's going on next door, but any number of possibilities are evolving. The world that you're not observing is branching into many possibilities. Relationality and consistency make this possible. Relationality is the idea that observations that you make of the world are between you and the things you're observing, that the world defines itself and falls into place relative to your perspective. And clearly, I have my perspective, and someone else has their perspective. What's required in order to make these perspectives line up is consistency. And that's all that's required, relationality and consistency. Relationality and consistency are a conspiracy of ever-widening correlations. Everything you interact with becomes correlated with you, and it means that you are now consistent with that thing. And if someone else comes along, you become consistent with each other. So we get the same world that we experience today, but behind the scenes, there's this uncertainty. There's this branching of possibilities. Quantum mechanics is a study of what the world is doing when we're not watching it. There's a really cool model we can use to understand how this works. In gaming, in virtual reality, people from around the world interact with each other. And they have to do so in real time in order to make the gaming experience exciting. Now, each of them is playing on their own computer. There is not some centralized master computer controlling the game and sending out information to each person. There's a network of individual computers. Each person has their game rendered for them on their local computer. And yet all these computers are trying to render one single virtual world, so they have to communicate. They have to remain consistent in order to create a sense of real fun gameplay. They do this by sharing only the information that is necessary, that's relevant to a given user. The whole virtual world is not shared, only the parts that are relevant to be able to predict what people are going to do relative to each other. When I'm playing the game and I've been out of touch with you for a while because you're across the world and you have a bandwidth delay, I might not know what you're doing until at a final moment I do interact with you and I get the information sent to me, and it allows an entire history of yours to fall into place from my perspective. Relationality is like gaming. This model is called optimistic synchronization. It's a process used in gaming to guess what people are doing even when you don't have information from their computers yet. And it's a way of synchronizing disparate computers to create a seamless virtual world, just like the one we experience now, a seamless physical reality that we consider to be objective and definite, and yet maybe is composed of many branching possibilities behind the scenes. To make the virtual worlds compatible, computers only share relevant information. The histories of other players are flexible until the data is received, and then an entire chain of events falls into place. This is like retroactive event determination. This is like the light particle leaving the sun, traveling many different paths, and when it's observed on Earth, that particular path falls into place retroactively. When I interact with you, from my gaming perspective, your whole history falls into place in order to lead you to where you are with me. Life is a fence. The fence posts are the observations that we make as we go through life. We fill in the gaps with what we think is going on. We make up a story about how the world is happening when we're not around. But we don't have any information about that. What we know is when we experience a fence post, when we interact with each other, we agree on the circumstances. That's the consistency. But we make up stories about what's happening in between. That's the gaps between the fence posts. Relationality says that the world is defining itself from your perspective, and from my perspective, and from each person's perspective. A whole virtual world, essentially, is created around a given perspective. Except it's a real world. It's not a virtual one. If I want to switch from my perspective to, say, Dana's perspective, I have to let go of what I know about my world and what I've been doing and jump into her world. For her, she's in the Louvre, and I could be in Paris, I could be in Rome, I could be in Spain somewhere. Those are my branches. And she'd be interacting with a tree of possibilities that represents all those possibilities. So each of us has our own branching set of experiences. So when we ask, what about the choices other people make? The answer is, other people have different trees. All that's required is consistency. The trees have to line up. And definite reality is what you mutually share. When you come together, you experience a shared reality. And that is what we call the real world. I have to ask, do we influence other people's fate? I don't think so. Synchronicity is not a force. It's a way in which we select out from all the possibilities certain possibilities that align with the choices we make, that align with the experiences we're seeking to have. Like the light particle, we're not forcing the light to take a different path than it had taken. We're just selecting out the one that it actually had taken, and retroactively we decide that it had taken that path. All that's required is consistency and this relational perspective. So what is a synchronicity? A meaningful circumstance which becomes more likely because it leads to an experience you're seeking to have. Let me give you an example. If I walk into the subway station and I'm trying to get to a theater production across town, and I'm almost going to be late, so I know I need to catch this train, but I hear the train pulling into the station right when I get there. What a bummer. I know I'm going to miss it. But I decide to run anyway. In running, is it possible that I influence random circumstances in my favor to delay the train long enough for me to get on? That's what I'm going to ask right now. So when I run, I'm actually running because I want to experience a set of circumstances at the theater. If I catch the subway, or if I don't catch the subway, those are two different possible branches of my tree. And if I do catch the subway, there's a possibility I'll be on time to the play. And there's still a possibility I won't be on time to the play. So I've got a branch for each of those possibilities coming off of the subway. Now, I've also got the possibility I won't catch a subway, and I've got two branches there, one for being on time and one for not being on time. If I do catch the subway, it's pretty clear that I'll be on time. So I'm going to place a heavy apple on that branch. It's going to weigh down that branch more than the other branch. It's likely if I catch the subway that I will be on time to the play. And if I don't catch the subway, it's unlikely that I'll be on time. So I place a small apple on that branch on the right. And here's the key step. When I run, I'm actually anticipating the outcome. I'm anticipating the experience I want to have. I'm anticipating the sights and sounds of the theater, the orchestra. I'm anticipating the taste of popcorn in my mouth. I'm anticipating the feelings of friendship and connection that I have with the people I'm going to meet there. And all of these are experiences that I'm seeking to have. And my thoughts, my feelings, and my emotions are all activating around these experiences I'm seeking to have. And I suspect that when we anticipate experiences in this way, we actually influence those future branches. Any future branch that has the experience I'm seeking to have will grow an apple. If there's an alignment between that circumstance, in other words, I'm on time to the play, then there's an alignment between that and me actually experiencing the taste of popcorn on my tongue. So I put a big apple on any branch that has on time associated with it, and a small apple on the other branches. If I combine the apples and top and bottom and multiply them together, I get a large apple right in the middle on the on-time branch. In other words, if I catch the subway and I'm on time for the play, that's the branch that is most heavily weighed down. The other apples are smaller. And now when I combine branches, I want to find out what's the likelihood of the subway branch happening versus the no subway branch happening. I'm going to combine those with a weighted average, and I get another result, which is a big apple on the left and a slightly smaller apple on the right. And this is just representing the mathematics that goes into this process. Here's the punchline. The larger apple on the left means that there's a likelihood, greater than chance, that I will experience something which allows me to get on the subway. What is that something? It could be anything. It's a random event which becomes more likely because it leads to an experience you're seeking to have. Maybe a bicyclist tries to get their bike on, but it's a crowded subway and they can't close the doors for 30 seconds, giving me enough time to run down and jump on. Maybe the train ahead is delayed for a few minutes because of something on the tracks, and so this train can't leave the station. Whatever it is, the synchronicity is the random event which becomes more likely because of the outcome it leads to, because of the experience I'm seeking to have. So now I get on the subway and I'm home free. I'm much more likely to be on time to the theater. The other branch disappears, and this becomes my reality. I make it on the subway because of the synchronicity that showed up. So do I cause the train to be delayed? No. The train history falls into place retroactively to match the outcome I experience. This is retroactive event determination. Here's the tree of possibilities. Here's the apples representing all the branches of the tree that lead to experiences I want to have. And the synchronicity below is the delay of the train that allows me to get on the train, which leads to the apple branches where I experience the theater production. Again, a synchronicity is a meaningful circumstance which becomes more likely because it leads to an experience you are seeking to have. So you make choices every day. As you walk through the world, your choices are influencing what apples appear on the branches of your tree. Your choices are influencing the shape of these trees and which branches are weighed down by apples and which are not. Your choices are influencing the likelihood of whether something will fall in your lap or not on a given day. You're making choices every day. Make them count.